Welcome everyone to the 2025 Pyohio. I'd like to introduce Mike McCaffrey. He is a programming and IT guy, and thanks for your patience as we had to figure out how to troubleshoot the local hardware that we're not familiar with. But we're up and running, and I'll hand the mic over to him.
All right, well, thank you all, and particular thank you to Anurag and the other chairs of the conference. I thank them specifically for their help with my show and tell here. I really appreciate it. This is my first ever presentation, and so I'm new. So everyone, cut me a little slack. Also, I'm from Michigan. Who's from Ohio? Most everyone. Okay, so I thought rather than talk about my sign, we should spend the next 25 minutes talking about the Toledo War. 1835 to 1836. What's called the Toledo Strip was very poorly defined, and Michigan claimed it and Ohio claimed it. They actually mobilized their militias. Fortunately, no one was killed. They were so mature that the governors of both states actually imposed criminal penalties for residents of the Strip if they submitted to the other state's authority, because that's a really adult way to solve the problem. Eventually, the federal government resolved it. They better defined the border. Michigan got a beautiful Upper Peninsula. If you ever want to go vacation up in the woods and see waterfront, highly recommend it. You folks got Toledo, and you got Tony Pacos. That concludes the Toledo War. So let's talk about Lights Python in action. So I'm an IT guy, programmer. On my last job, I did some work where my code was very adjacent to industrial electronics. So I've been wanting to do a project like this. And here it is. Pardon me while I'm recording, which is way over. This is why we all have jobs, and that never works. All right, so we got nothing on the side, right? That's about the way these things are going this morning. I did forget one thing. Pardon. Electricity's hard. I probably have to jump start the sign. It's got to fill up. All right, so now we're fully charged for business. That was gag number 2. No applause. I promise there's no gag number 3. All right, so I had a bunch of these porcelain light fixtures in a box, left over from when I redid the basement. I also had a table saw that had never been used, still in a box. And I had a son graduating from college. This was a little over a year ago. I wanted to do a project where my code was actually interacting with something physical. So I bought this mechanical relay module from Model Labs. It seems to be a really good, reliable brand. The clicking of the relays, when you turn them on and off, they click, sort of reminded me of drums. The board emulates a legacy serial port over USB. So the first module I needed was Pi Siri. That's pretty straightforward. It let me read and write to a virtual serial port with no commands to the yard. Here's the back of version 1 of my sign. Very few components. The relay board, 10 lamps, little Raspberry Pi, little power supply, not too much else.
Here's the completed version 1 of the sign. My son graduated from Alabama, so he is a Bama grad. So we use that as graduation party. This sign is a little bit different. This sign has 12 lights. The original sign had 10, kind of like that, but the sign was rotated. So it was kind of more like this. That's kind of what the original sign was. Now we've got 12 lights, 3 by 3 by 3 by 3, which was a lot of work. I thought going from 10 lights to 12 would be a certain work. But now we can do things like this. So that was definitely worth the many, many, many hours it took to go from 10 lights to 12. Don't judge me. All right, one of the things I learned as over the course of this last year, I put a lot more components inside the sign, was that terminating a lot of wires can be really, really tedious, but if you learn about how to use better tools and acquire some better tools, it can actually go really well. So, if any of you folks are familiar with Knipex, it's a German brand. On the left is the Knipex automatic wire stripper. It is fantastic. If you guys need to strip some wires, buy yourself a Knipex automatic wire stripper. On the right is a set of wire end ferrules and a crimper for the wire end ferrules. The idea being you've got stranded wire, a whole bunch of different little ends of copper. You want to make it one solid connection, so crimping wire end ferrules is the way to go. Here's a really nice Milwaukee crimper. $40, it's going to sit in my toolbox for the next 20 years, but it was worth it. Crimped on some ring terminals in the lower left. And another German brand, which is fantastic, on the right is a Wago brand lever nut. So rather than the traditional wire nuts where you twist the wires together and you twist a nut on, these suckers, one wire per little lever. They come in 2, 3, 5 larger units. They work fantastically. They're approved now for use in the US. You can actually buy them at Home Depot. Highly recommended. You can use them for household electrical as well. So in the center here, it's a terminal block where all the wires are coming together. And every one of those wires is terminated with wire ferrules. And it just works really, really well. So I wanted to bridge from my code to the real world, right? So running on a Raspberry Pi, has a 40-pin general purpose I/O header. So you can get ins and outs, inputs and outputs to and from the thing to other devices. gpiozero is the recommended library for doing that. Works well. Here's a bit of code from their documentation. So import a button from gpiozero. You've got a function, define a button, and you define a callback. So you say, okay, button, when pressed, run hello. Hello's the callback. Works great. The one thing I didn't realize is it runs that callback in a separate thread. So I had some weirdnesses because I didn't realize I had 2 threads running. So I had to figure that out. So the threading module has several resources for communicating between threads, one of which is an event. So you see here, I initiate a threading event, and I say, might get button. When it's pressed, go run this callback button pressed. The button pressed actually uses the event and it runs the set method on the event. That event is visible to all the threads, so that the 4th section of code, all the time when the sign runs, everything's paced. So we do something and we wait, we do something and we wait. Rather than do a time sleep, I do a wait method on the threading event. And you say, okay, wait for a 10th of a second. It'll either wait for a 10th of a second, or if the button's pushed during that time, in this case it raises an exception. My code says, oh, okay, well, the button was pushed, so go act accordingly. Initially, it was just a button on the back of the box and it's still there. So if you can picture, you don't have to picture me, but picture me in my garage with my feet up in front of the sign, getting the lights to look at nifty patterns, and I want to press the button, but the button is way on the back of the sign. I I said, my feet are up, and I really don't feel like getting up. So the next module I used in the standard library was Signal. Works extremely well, very simple. Define a callback, say when the process gets, in this case, the CPU user 1 signal. Here's the callback, in this case, virtual button pressed. And so I'm in a shell, and I do a kill command. Instead of kill dash 9, I do kill dash CPU user 1 to process ID. And when I'm up, I push the button without actually getting up, reaching to the back of the sound. I gotta say, it's one of the easiest things that just worked. No problem whatsoever. For those of you not familiar with a Raspberry Pi, upper left is a Raspberry Pi Zero, actually version 2. It's remarkable what this little guy does for about 15 bucks. You see the 40-pin header at the top, GPIO header. The unit at the bottom is a third-party, they call it a hat, because the modules stack on top of each other using the 40-pin GPIO header. This hat is a USB hub with several USB-A ports and an Ethernet jack. And then finally, on the right-hand side, I've got sort of a top hat, I guess, which terminal screws for all 40 connections and little lights so you can actually diagnose at a hardware level what pins are high, what pins are low, what's working, what's not. I'm old school. I didn't want to, I could have SSH'd into the Raspberry Pi, but I didn't feel like I wanted to do a serial port. And I already know there's one person in the audience that looked at it and said, that's an RS-232. Who here is old school enough to be using physical serial ports? Quite a few people. All right, fair enough. Anorak's leaving out of shade because it's never used a serial port. Who remembers when they were 25 pin rather than 9? Pretty much the same group of people. All right, excellent. So I had one button. Like I said, I didn't really like getting up to press it. So I wanted more buttons. So I got a remote control and a receiver for it. Adafruit is a great, there's really no lack of companies online selling accessories for Raspberry Pis and similar devices, but Adafruit's a good one. So wired this up, the receiver, and it's 4 more buttons wired into the Raspberry Pi. One note, you get what you pay for. This guy's like $6, right? It died, the previous one of these died 2 days ago. I had to pay $26 for overnight shipping to get a replacement for a stupid little $6 remote. So you guys, like you folks all know this, you get what you pay for. Should have bought $50. One thing I didn't know about, many things, that little wireless receiver, like a lot of devices, operates on 5 volts. So you press a button, it sends 5 volts to its host. Raspberry Pi operates on 3.3 volts. So there's different ways of addressing that. I'm not an electrical engineer. The simplest way is a level shifter or a logic level converter. You simply wire this up and it's bidirectional. If it gets 5 volts over here, it sends 3 over here. If it gets 3 over here, it sends 5 over here. So it's a great way to bridge between devices with different compatibility parameters. All right, let's get the sign going. Next thing, after I was tired of buttons, is I wanted dimmers on the bulbs. So we've got dimmers on the bulbs. Plus it's optional. Ooh, not bad. Thank you. This Shelly brand, anyone that's interested in home automation, this Shelly seems to be a real solid brand with dimmers and relays and sensors, lots of smart home type devices. What's great is that it's got a completely open and extremely well documented API. It's not tied into Google's closed ecosystem or Amazon's closed ecosystem. It's just open, and they had really good luck with these. This particular model has 2 independent channels, and I've got a bulb on each independent channel. So it means I've got 6 of these suckers in here. And here they are on the left. They're just passively cooled, and it's just 120 volts in, 120 volts out. So to deal with the potential for heat, you see they aren't adjacent to each other. I've actually spaced them out so that we can get some convection going and natural airflow going. And now they run quite cool.
Another thing I learned, sometimes you cannot get away with doing things sequentially. I come from a world where, you got to iterate over 50 things or 5,000 things, you just iterate over those 5,000 things. I've honestly not done much anything with parallel code, but so this is what happens when I just iterate over my 12 channels and I say go from low to high. And I thought, oh gosh, that's gonna happen in a couple milliseconds. I will possibly see a sequentialness there. And I do though. The reason is I was just using requests, which is of course a very popular third-party web interface module. And I was just sequentially issuing request commands. But it was waiting for the response from each unit before it would go to the next. So it sends command here and it gets a HTML response. It sends a command there, it gets a response, etc. And as great as these little devices are, they're a little bit slow on sending the responses. So hence this delay. And it might be good enough, but when it's your project, you want it to work the right way. So now we've got them truly going sequentially. So I learned about async IO and aiohttp third-party library. I'm not qualified to get into async IO or aiohttp, but the main point is, in a little bit of code, you can send out, hey, send these 12 commands out, one to each layer. Collect the responses back in whatever order they come. When you've got all 12 responses, then send me the responses back. And the result is, things are working pretty consecutively. Type annotations are fantastic. Probably don't have to convince a lot of you of this. This was the first project where I really used type annotations. I was just amazed at how much time they spent. It saved me. I do occasionally, I'm using just Visual Studio Code, Pylance, and Pyrite. I do occasionally get a situation where it says, oh, there's an error, and there's not, but I can't really argue with it. But I restart VS Code, darn if the error doesn't go away. And occasionally, Pyrite can't infer the types properly. This would be an example where you'd think it would be able to tell that by the bottom of this code, transitions is a list. It doesn't. That's fine. You put an assert in. And I found that the asserts really help with the self-documentation of the code. So I just really bowled over by the typings in the supporting ecosystem. Getting a little bit low on time, data classes. Who here uses data classes all the time? Okay. I've been blown away, first project where I really used data classes, how much boilerplate code it eliminates. Dunder init, dunder string, dunder repr, equality dunders, etc. All of that stuff's just taken care of, and code just gets so simplified. So here's a data class which really is just 6 fields of data. Nothing too special there. Here's a data class where we've got some fields of data. Some are initialized init, one isn't. Some is handled post init, which is called automatically by the generated class. Also, I was using frozen data classes here, which gives you pseudo-immutable data, which I thought was a really good way of thinking about things. I was always just willy-nilly assigning properties here and there, and attributes. And using this forced me, because there is a workaround, we can do an object.setEditor, but it forced me to, wait, why am I doing that? Do I really need to do that? If so, should I do it in posting it? Or if I'm changing things downstream, maybe I just want to delete, let that object get garbage collected and create a new object. So I found it a really good way of thinking about things. Dependency injection. Who uses dependency injection? Okay, I learned a ton with that. I won't cover that now because we're running low on time, but really learned a lot. Separate where the resources are created versus where they're used. Just really cleaned up my code quite a bit. And of course helped with testing and such. Abstract base classes and interfaces. got a lot of objects where A refers to B and B refers to A, and maybe that's not the best way of designing it anyway, but I found that abstract base classes allow me to just boil it down to what are the public methods that I need to advertise in the interface, and the rest of the stuff can be handled in a concrete class. I think I hopefully I read up my game with these things. Of course, data classes can have not only data, but they can have abstract methods, they can have concrete methods, and I just found it works really well. Once I learned a couple of the works, it's just, there's no looking back in my mind. Music is in the high and beholder. Wanted this to have sort of a musical engine to it for the rhythms and such. So anyone familiar with musical notation will, more or less, if you squint, see, yep, okay, there's musical notes and rests, and the concept of instruments and parts and such. 30 years ago, I bought a string of mechanical musical Christmas bells for my parents. And I always thought, it's got this big string of wires. I always thought, well, it'd be cool to reverse engineer that. So I finally got the chance. So you can buy these easily on eBay. 9 real bells and plays 12 Christmas carols. I wanted to fire those bells on my code. So rather than a mechanical relay set, I got a solid state relay set. So when these relays trip, they're silent. And so you can ring bells without making extra noise. Some lessons learned, I kind of mentioned along the way, other than fiddly 30-year-old bells maybe aren't the best way to spend your time. Also, I reinvented the wheel. I should have probably used an existing music library. And I also learned I really should resist the urge to plow ahead without tests and support code. Like a little pretty print function I wrote like last week that I should have written a year ago because it really simplified things. And finally, music is in the eye of the beholder. Credit to my brother Kevin for helping me with some of the musical aspects of this. If you guys don't like this, please see him. I don't know about you, when I think small Christmas bells, I think 1970 hippie counterculture rock anthems, right? And so, having said that, you guys heard that at all? Thank you all very much. We don't have time for questions, but you can see me in the hallway.